Welcome back to Remote Production, our online course where we're going over bandwidth and bit rates. This is so important, understanding what your internet connection is, both on the local area network where you're connecting up devices, and then on the receiving side, right, on the remote side. We're going to go over all of that, the tools you need, and how important it is. So remote production has really come about because we have internet connectivity, because we have bandwidth. We can remotely access and control remote locations. So it really is predicated that we have this good internet connectivity. And from there, we can start using some of these IP connected devices very easily, whether it be NDI or Dante, because we have connectivity on the local area network. We can bridge that to the wide area network. But things can break down when we don't have good internet connectivity. So remote production comes from that internet connectivity, and it can allow us to not have to travel and not have to go into different on-site scenarios because of remote production. But we really need that high-speed internet connectivity to have real-time transmission of data, and it's really essential. So we're going to go over some of what the difference is between bandwidth and bit rates, right? So bandwidth is generally measured in bits because we're talking about generally the upload and download connectivity that you have either with the internet or with your local area network. And then the bit rate, right? That's measured in how quickly. So that's a rate. So that's megabits per second. So you might have a 1080p megabit per second stream, which is 6 megabits, or you might have a 2 megabit per second stream. So a high quality stream has a higher bit rate and a low quality stream has a lower bit rate. Now, there's a report out there that says 6 megabits per second is an excellent quality 1080p stream. And each stream, it can be encoded in different ways. It could be encoded in H.264. It could be encoded in H.265. It could be encoded in AV1. I'm not going to go into every single one of these right now, but as you can see, the higher the resolution and frame rate, the higher the bit rate that's usually recommended. A lot of this really starts at, are you doing a 1080p stream? What's your frame rate? Is it a 4K stream? What's your frame rate? And then what quality are we streaming in? All the way from 60 megabits per second down to 1.5 megabits per second, which is kind of as low as it goes with a 720p 30 frame per second stream. So I want to look at this like high level look at a network at this point. We've got a router, and the router is given to us by the internet service provider. Maybe, whoever you pay for your internet from, they give you a router. It connects you to the internet, and you can then connect it to your network. And all the devices on your network, whether it be a smartphone, a smart TV, a computer, a printer, can receive internet access. Now, oftentimes, companies will put a firewall in between. Sometimes there's already a firewall in the router, but a firewall will protect you from people coming in from the outside and trying to access your devices. And then connected to your network, of course, can be wireless access points, which allow us to connect devices. Now, when we're streaming to YouTube and Facebook, we're streaming outside of your local area network. So we're using upload speed to get to YouTube and Facebook. But I want to show an example here of your local area network first to kind of explain how this could be working. So a lot of times an NDI video stream can be upwards of 100 megabits per second. It could be more, it could be less, depending on how you're doing it. Full NDI HB, high bit rate NDI can be anywhere from 100 to 200 megabits per second. And then NDI HX, high efficiency cameras, can be as low as 6 to 20 megabits per second. But no matter what, your local area network has a limit to how much bandwidth it can handle. And if you have a gigabit network switch, meaning 1,000 megabits, you've got to think about how many video sources can a gigabit actually handle. In this scenario, we have a vMix system that's outputting NDI for 100 megabits per second. We're using a telestrator, which is something that's used in sports. It allows you to draw on top of the live video. That's another NDI source. We've got, let's say, 3 more NDI sources. Maybe they're screen captures that are being used for esports. And suddenly we're using 100, 200, 300, 400, 500 megabits per second, which is totally fine. If you're using Ethernet cabling that supports gigabit transfer, meaning Cat5e or newer or greater, if you've got a gigabit switch. And then we're adding some cameras, right? We've got NDI-HX cameras, which are high efficiency. They don't use quite as much bandwidth. But how does all of this work, and how can we make sure that it works? So one of the things I want to do is a speed test. And one of the things you'll notice here is that I'm getting 566 megabits download, 200 megabits upload. So I can stream in 4K. I can download in 4K. I can do some crazy stuff. But a lot of people can't, and we need to be able to run these speed tests and adapt to the bandwidth that we have. It might be a field in, an athletic field that you're helping to live stream. So how do we control all of this? Well, that was the internet speed that I have from my router, from my internet service provider. This right here is Task Manager on Windows. There's a similar situation on Macs. This is how much bandwidth I'm sending and receiving on my local area network. So I'm sending an NDI video feed to Mike, our producer for this production, and that's sending 126 megabits per second. So my one single NDI stream coming from my computer, 120 megabits per second. I'm also receiving 46 megabits per second roughly, right? So I'm receiving some NDI video. That probably has to do with the Hive. In fact, I'm receiving this 40 megabits per second here. That's probably all coming through the Hive, which I'm going to transition to really quickly to show the video monitoring here as well, because this is really important stuff to understand. So Hive has a monitoring tab at the top right, and this is really important because you can monitor video sources that aren't on your local area network. So these video sources might be in the cloud, right? They might be somewhere far away from you, and you need to take a look. And you might say, okay, well, this CPU, this computer is only running at 4%, so it's obviously doing okay. I've got 1, 2, 3, 4, 5 cameras connected to this cloud account here, and they are, coming through here. And what I can do, and the reason why it says 0 bitrate, by the way, is because I'm connected over the local area network right now. But if I connect it to the cloud, then what's going to happen is it's going to actually download these sources through the cloud. And I'm going to do that for this example. I'm on this local area network, but sending them up to the cloud is probably a good idea right now, because we want to be able to do this for our demo. So one of the things it's saying here is that my video sources are poor quality, and that's just because I have them coming in at 720 for this demo. Ignore that. But this cog right here, what this allows us to do is actually adjust the bit rate of the camera. And the reason why that's important is because you might have limited upload speed, right? And let's say you have 20 megabits of upload speed. Well, you probably only want to use, if you've got 4 cameras, then less than 5 megabits each, right? So this is your bit rate. So this bit rate is 4,000. And it's 30 frames a second at 1920 by 1080. That's what's streaming up to the cloud. So this is how you can adjust your bit rate remotely and can literally adjust the upload speeds that the remote end is sending. So something to consider if you're having bandwidth issues. I'm going to flip this back to local mode now, and you'll see that Hive supports both local mode and remote mode. But you can see here, that is how we can adjust bit rates. So I think that's important as we go over this. You'll see that there's different access to bandwidth in this world, right? And you need to choose a good internet service provider. It might even be a cellular bonding situation where you're bringing out a cell phone or multiple cellular connections to stream from a location. And if you have limited upload speed, you want to really make sure that your cameras are set and all of your devices so that they operate within the upload and download speeds that you have access to. Now, of course, you want to do backups and have backups. And one backup internet solution is always good to have. You can bond different solutions together, and Speedify is a great solution for this, where you can bond cellular with a mobile hotspot, with satellite internet, with Wi-Fi, with hard wired Ethernet, and you want to conduct a dry run. You want to do a speed test at your locations when you're doing remote production. So as a takeaway here, we've got this global connectivity. We have these large IP networks that allow us to do remote production. Having high-speed internet is really crucial. But how good is your internet? Run a speed test, check what you've got, and then adjust your cameras. Adjust the bit rate of your encoders and decoders in your devices to work within your limits. And of course, regular testing is important. I hope that was helpful, and I can't wait to get into our next chapter of remote production, which is the core components of remote production. We're really going to start digging in. I'll see you in the next video. Whew. Core components.